Hello and welcome to this lesson on derivative rules, review of derivative rules. So what I have here is a list of functions and their derivatives. So the function f of x is equal to c, where c is some constant. The derivative of a constant is 0. The next function I have is if f of x is equal to x, well, the derivative of x is equal to 1. Our next function, f of x equal to x to the nth power. So this is sometimes referred to as our power rule. So if I want to take the derivative of x to the nth power, I bring down the exponent, making it a coefficient, and then I subtract 1 from the exponent. Bring down the exponent, subtract 1 from the exponent. Our next function, the derivative of e to the x, remember e is Euler's constant, is 2.718, and it's a long decimal like pi. So the derivative of e to the x is e to the x. Now, if we have an exponential with a base number other than e, like if this was a 2 or a 7, well, if I've got f of x equal to some base number to the x, then the derivative of b to the x is equal to b to the x times the natural log of b. The derivative of the natural log of x, that is log base e, the derivative of the natural log of x, that is 1 over x, the derivative of log base b of x, so the derivative of log base b of x is going to be 1 over x times the natural log of b in that denominator. Now, the derivative rules for our trig functions, well, the derivative of our sine function, the derivative of sine is cosine. The derivative of cosine is negative sine. So the derivative of sine is cosine, the derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cotangent is a negative cosecant squared. So the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant times tangent. The derivative of cosecant is negative cosecant times cotangent. Now, the way I remember these 6 trig derivatives is I basically have them memorized in pairs. The derivative of sine is cosine, the derivative of cosine is sine, with a negative in front. The derivative of tangent is secant squared, the derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent, the derivative of cosecant is negative cosecant cotangent. So when you look at these pairs, there are similarities in the pairs. And then for whichever ones get the negatives, well, if your function starts with co, its derivative gets a negative. So the derivative of cotangent is a negative sine. The derivative of cosine is a negative sine. The derivative of cotangent is a negative cosecant squared. The derivative of cosecant is a negative cosecant cotangent. So all of your trig functions that start with the word co, when you take their derivatives, those pick up the negatives. All right, here are some additional derivative rules. So here, these functions f of x and g of x are referring to these functions up above here. So this derivative rule here says if I have a coefficient times a function, and I want to take the derivative, well, I'm going to keep the same coefficient, and then I take the derivative like I normally would, and then multiply it by that coefficient. So a coefficient in front of a function stays in front of that derivative, and then you multiply it by the result. The next 2 derivative functions, well, if I've got 2 terms that are either added or subtracted. So if I have 2 things up here that are either added or subtracted, then I can take the derivative term by term. The derivative of the first function plus the second one, or the derivative of the first function minus the second one. The next rule is sometimes called the product rule. So if I have 2 of those functions that are multiplied, well, the way I remember the product rule is, so if I've got 2 of these functions multiplied, it's going to be the derivative of the first function times the second plus the first function times the derivative of the second. So that's the order in which I have it memorized, and that's called the product rule. The next one is my quotient rule. So if I need to take the derivative of a fraction, well, what I'm going to do is I'm going to do the derivative of the top times the bottom one minus the top one times the derivative of the bottom one all over the bottom one squared. So that is my quotient rule. And this one here, this one is called our chain rule. So what this says is I've got one of these functions embedded inside of another function. So an example might be something like having the sine function written inside of an exponent, or any one of a number of combinations. Oops, too far. So the way I think about this is I'm going to call f the container function, and g is what's inside the container function. So this is the derivative of the container, where the inside stays the same, and then times the derivative of the stuff on the inside, and that's called the chain rule. Alright, since the chain rule is used a lot in conjunction with all those other functions, I have rewritten all those derivative rules, but I've also written them where u represents some algebraic expression, some function with x as a variable, and du represents the derivative of u. So rewriting all those formulas before, well, the derivative constant is still 0, the derivative of x is 1, the derivative of u to the n exponent. So if I had something like a square root of, and then inside that square root I had a whole bunch of algebra, well, I bring down the exponent, subtract 1 from the exponent, and the stuff inside the grouping symbol stays the same, and then times the derivative of the inside stuff. Same thing for my e. So if I had an e to the, x squared up here, then that would be e to the x squared, and then times the derivative of x squared. And I've done the same thing for all the rules above. So these are all the rules that we saw before, where I've embedded the chain rule inside of all of these. So if the base number is not e, well, here's the first part of that derivative rule. So it's going to be the derivative of b to the u times the natural log of b, and then times the derivative of what was ever inside that exponent. Did the same thing here for the natural log, so it's going to be 1 over u times the derivative of whatever u was. Same thing for that log base b. Same thing for all of our trig functions. So the derivative of sine of u is going to be cosine of u, and then times the derivative of what was inside the trig function. Same thing for cosine, tangent, cotangent, secant, cosecant, and so forth. And then these last few ones, well, I did not write those as a chain rule because those really don't change. But yeah, if there was a chain rule involved, then you would have a derivative of the inside out in front of all the rest of it. So this right here is a quick little review. I did not do any examples, but this is a quick little review of the derivative rules.